What's up, everyone? Welcome back to the Crypto Mavericks podcast. And we have a great guest here for you today. It's Carter Feldman. He's the CEO, he's the founder of Psy Protocol. It's a next generation zero knowledge proof blockchain. We're going to talk to him about the blockchain. We're going to talk to him about the difference between proof of work, proof of stake, kind of the 101 behind that. But Carter, really happy to have you on the podcast today.
Thanks so much for having me, Brian. It's a real pleasure.
Yeah, it definitely is. And anybody watching or listening, we may have a little bit of interruption on the audio. We're going to do our best to clean it up. He's actually joining us from afar, so really appreciate him breaking away some time and joining the podcast. But before we jump in and we start talking about proof of work and proof of stake and zero knowledge proof blockchains and what you're doing inside protocol, I want to know about your background. How'd you get into the world of Web3? How'd you get into the world of basically blockchain?
Sure. So my first, I guess, inklings of blockchain came when I was a teenager. I was a relatively well-known black hat hacker, and in return for hacking services, I received Bitcoin. So I earned my first money was paid in Bitcoin. So I guess I've been one of the few people whose first job was truly crypto native. I'm a Mt. Gox user, so very early Bitcoin user. I really got my feet wet professionally in crypto. Say about like 5 or 6 years ago, I was an EOS top 21 block producer. EOS blockchain back in the day, was the most performed blockchain, in the industry. Vitalik called it Ethereum on steroids. And that was like the first really big proof of stake blockchain. Now, for those out there who don't know, proof of stake is kind of the current industry standard that a lot of blockchains use. Solana, Tron, like these blockchains, have adopted proof of stake. But yeah, so I was an early proof of stake devotee, and now I've decided to defect and join Team Proof of Work.
All right, amazing. And I saw that in your background, and we're going to dive a little bit deeper into that. I want to know how you went from a proof of stake guy and now a proof of work maxi. But in your background, what a wild background. So you were a hacker, like a paid hacker, a hired gun out there, and you were getting paid in Bitcoin. What a cool story.
Yeah, so I don't want to go too much into the details of some of that just because of statute of limitations, maybe not necessarily lapsing, but I was very well known. Some of the things I can't talk about. So in the video game hacking sort of scene, I was very, very well known. I worked with a group called Xbox Underground. I helped like the first worm virus for video game consoles. So if you joined my game, I could then infect your console with virus, and then any game that you joined on, anyone who you interacted with would also get the virus. So I was a sort of self-taught programmer kind of a guy. Later made like the first mod platform for the mobile version of Minecraft called ModPE that had like 20 million downloads. And then I went to college, eventually dropped out, and I also have a background in the gaming industry. I'm on the board of Ninjas in Pajamas, which is a publicly listed esports company. Also now doing some Bitcoin mining. I guess crypto kind of comes naturally when you like, especially back in those days, the main use cases for crypto perhaps were a little bit darker. Than some of those that we see today. Like that was kind of in the days when WikiLeaks didn't want to take crypto donations because they didn't want any affiliation with like the sort of Silk Road scene that was evolving at the time. So yeah, I mean, we've come a long way from there, and I think a lot of the other people that were into crypto then have kind of matured as I have learned not to break the law. So yeah.
Yeah, amazing. All right. Well, we won't talk any more about that, but honestly, a very cool and interesting past, and we'll talk more offline about some details. We'd love to know, give our users a little bit of an insight of what Psy Protocol is and what you've built.
For sure. So, I've always been really excited about scaling blockchains past just basic things like payments. So, obviously Bitcoin is the best digital gold. No one's going to challenge on that, and we think Bitcoin is great. But the same values of trustlessness and decentralization, have always been very attractive for me, and I've always wanted to, spread those values to other things just besides payments, right? To the rest of the internet, essentially. The reason why I got involved with EOS is because I wanted EOS was super scalable, and you could build applications that, were trustless and decentralized that you couldn't build anywhere else. So with Psy, really, we wanted to build a blockchain that could scale the values of trustlessness, decentralization, and anonymity to the full internet scale. And that's always been a real challenge for blockchains, just because, generally the way blockchains work is everyone has to process every transaction. So every node, every time you send an Ethereum transaction, every single Ethereum node is going to run it. But we invented a new kind of blockchain that uses zero knowledge proof to allow the nodes to split up the work of proving the block, and therefore we can scale to like millions, tens of millions of concurrent users using the chain. So Psy Protocol in a nutshell, it's taking all of the great decentralization, trustlessness, anonymity that you get with things like Bitcoin and Ethereum, but allowing big applications like you can think social networks, Amazon, eBay. This sort of scale of applications can now be fair, trustless, and anonymous. So yeah, we're doing some exciting stuff.
Amazing. So, for someone brand new to crypto, can you explain the difference between proof of work and proof of stake?
For sure. So it's all about rewarding the people that secure the network. So with proof of stake, people get rewarded for securing the network by running validators. And the way that they become one of these validators is basically you can imagine that for every dollar of the cryptocurrency you have something like a vote to decide who the validators are. And then the validators get a percentage of the chain's inflation. So as we know, like the Federal Reserve goes a printing away. And we can imagine that some of that money printing is going into the politicians' pockets, and that's kind of what proof of stake is. Like by running the chain, you get money through inflation. With proof of work, you get paid for doing work that secures the network. It's like very, very straightforward. And the critical difference with this is that with proof of stake, if you're not super rich, you don't have a lot of the token, there's no chance that you're ever going to be a validator, right? You got to accumulate a ton of tokens to be a validator. With proof of work, anyone can mine a Bitcoin block. You can mine a Bitcoin block. You can mine a Bitcoin block without having, ever owned any Bitcoin. So it's truly decentralized in the sense that there's not this in-group of oligarchs that kind of control the chain. But of course, with proof of stake, what we've seen is that those chains are faster. They can handle more transactions than some of the proof of work blockchains, just by virtue of having to have this proof of work challenge that's fair enough. But again, with proof of useful work and these zero knowledge proofs, which is a really cool thing that hopefully we'll be able to touch on, we sort of are able to take those same benefits of decentralization and also scale up the chain.
Yeah, and that was a perfect segue to my next question. So, Psy Protocol claims to be a zero knowledge proof blockchain. To a really non-technical person, what's a zero knowledge proof blockchain?
Sure. So first of all, we got to talk about zero knowledge proofs, which are super, super cool. And all you can imagine, all you need to know about what a zero knowledge proof is that there is this fancy math. So we all know what mathematical proofs are, right? There's people in universities proving that some equation equals another equation, stuff like that, right? Now, it happens to be the case that there's a way to generate a proof that some program ran and yielded a certain result. So you can imagine going back to math class, you'll have something like y equals 3 times x plus 4x squared or something like that. And maybe when you're doing a test, you have to show your work to the teacher and show that, okay, this equation actually is satisfied, right? So a zero knowledge proof is just a way of converting a computer program, like something that's, let's say transferring money to someone, or running an AMM or running a DEX, and translating it into some equations that then can be used to generate a mathematical proof. And it happens to be the case with this magical, what some call moon math, that the size of the proof, the time it takes to verify this proof of some computation, is much faster than just rerunning the computation. So it happens to be the case that let's say I want to run 1 million transactions, right? That's going to take a while. It's a lot of transactions to run. You can imagine sitting there marking down a ledger. Okay, Tom's going to send 10 to Tony, so Tony's balance is not going to increase. We got a lot of computations to do. But it happens to be the case that generating and verifying a proof rather, of 1 million transactions using a zero knowledge proof takes the same amount of time as it does to verify a proof of 10 transactions. So a zero knowledge proof is a way of proving that some computation executed in a certain way which is faster to verify than just repeating the computation. With existing blockchains, again, whenever you send out a transaction on Ethereum, how do we secure the network? We have everyone repeat the transaction and make sure everyone gets the same result, right? But with these proofs, what you can do is I can have one node that's going to run the transactions or run 10 of the transactions. It's going to generate a proof of those transactions. And then instead of having the other nodes redo the 10 transactions to make sure everyone gets the same result, it instead just provides that proof. And the really cool thing that you can do, and this is what we call zero knowledge proof blockchain, is you can take, let's say, maybe, Brian, you're going to approve 10 transactions. I'm going to approve 10 transactions. Now, if anyone wants to verify that block, they just have to verify the two proofs. But what we can do after that is generate another proof, which proves that your proof is valid and my proof is valid. So now we start with 10 transactions, which might take a second to verify. And we've turned it into two proofs and then into one proof. And now anyone can verify those 20 transactions in less than half a millisecond on their iPhone. So you're able to, the main thing there and why we call it proof of useful work is that we're able to split up the work of proof of block. Which again you can't do with other blockchains because everyone has to repeat the same work. So we can't share the work. And critically, adding more nodes to the Ethereum network doesn't increase the capacity of Ethereum, but adding more nodes to the Psy network makes it so we can support more people. Hence why we can support millions of people on the chain. It's just a matter of adding more nodes. If that makes sense.
Yeah,
maybe that was too technical.
No, that's great. And the technical people probably will be eating that up. People hear about the blockchain trilemma a lot. What exactly is that?
Right. So the basic idea behind there is that the way that existing blockchains are architected is such that if you want to get scalability, decentralization, and some censorship resistance, it's very hard to mix and match those. Because once you try to start scaling things up, well, the obvious way to scale things up is to split up the work, right? So let's say we got to do 100,000 transactions, right? That's a lot of transactions to do. You're going to do 50,000. I'm going to do 50,000. If we split up the work like that and we don't use zero knowledge proofs, we'll be in a situation where you're have to trust that you verify those 50,000 transactions correctly, and you have to trust that I verified the 50,000 transactions correctly. So basically, instead of having to, just be able to not trust each other, so essentially like no node has to trust another node, we now have decreased the number of individual nodes that verify each transaction by a factor of 2. So you can imagine if you have a network of 1,000 nodes and you verify each transaction on each node, then every transaction is verified by 1,000 people, right? Which is very secure. But if we want to split it up and maybe we got a 500 group of another 500 group, now we're in a situation where every transaction, we can double the amount of transactions we can process, right? But every transaction is only verified by 500 people, so the security goes down. So there's this core relationship between the sort of like amount of transactions that you can handle and the number of people that you have checking everything. And then on top of that, we also have this issue of censorship resistance, which has to do with the fact that when you make transactions available to the chain, you need to allow a certain amount of time to pass so that that transaction can be propagated to all of the nodes, right? So you can imagine, let's say I don't know, maybe I'm in Singapore. I'm going to send my transaction over to the Singapore server, right? The Singapore server then has to send those transactions to every other node around the world, right? Before the block is created. So you need to have enough ample time for that to occur before creating the block. Otherwise, you end up in a situation where the transactions sent to the Singapore nodes are only going to be processed by the Singapore servers, and they could censor you then, right? So like there's always been this issue of speed and how many transactions do we want. And previously, these blockchains have just either increased the security by decreasing the scalability, or they've gone and they said, okay, we're going to sacrifice some security and give a better user experience and more scale. So you can imagine the Trons of the world, the Solanas of the world. They've taken the point that we want fast, we want scale, and we're still going to have some decent security, but we're willing to sacrifice a little over something like Bitcoin. But the problem, of course, with all of this is that Solana can't sacrifice too much security, right? Mm-hmm. So even though they're scalable, they can't really make it more scalable without decreasing the security to a point where it's no longer a blockchain, right? And the reason why we want things to be a blockchain, just so everyone remembers, so no one can steal your money, right? if someone could take your money, then maybe I trust Bank of America than I do one of these anonymous nodes, right? I can sue Bank of America, right? But I definitely trust Bitcoin more than Bank of America. So there's this like spectrum. And previously, we haven't been able to really crack the code of that. Fortunately, now with recursive zero knowledge proofs, we can.
Okay, perfect. So size proof of work, like proof of work 2.0, I think I even saw it like described of. And I want to give like a little context for all the listeners out here. Bitcoin runs on proof of work, and that's probably not changing anytime soon, if ever. Ethereum, another really major blockchain everyone's probably familiar with, used to be proof of work, and I think it was like 2022, September 2022, it was called the merge, and Ethereum merged from proof of work over to proof of stake, and it was a real big deal to all of us like kind of geeks in the blockchain world. I was like real excited about it, and it was getting headlines in our circles. But to like the normal retail customer, they probably have no idea what the difference is, and that's why we're trying to give you a full understanding of the difference between currently Bitcoin is proof of work, Ethereum is proof of stake. And you gave a great explanation the difference between proof of work and proof of stake. And size proof of work, basically 2.0, they call it. How does that differ from Bitcoin's proof of work?
Sure. So the way that Bitcoin's proof of work works is that every block there's a math problem that everyone tries to solve, and the miners are racing to be the first one to solve that problem. And only the first one that is able to solve that math problem gets the Bitcoin reward and gets to mine the block. So everyone else, all that electricity that they use, all that computation that they spend is wasted essentially. And critically, adding more miners to the network doesn't improve the user experience on Bitcoin. It doesn't make it so that more people can use it. And as we know, when Facebook wants to support 1 million new users, they just add some more nodes, they add some more servers. But with Web3, we haven't been able to do that due to proof of work's limitations, right? Because again, only the first node that's able to solve that math problem gets the reward. So what we've done with POW 2.0, or what we like to call proof of useful work, is we're able to take all of that compute power from all of those miners, and instead of having them compete against each other, they actually work together to build the block. So like we were saying before, you're going to prove these transactions, I'm going to prove some other transactions, and then maybe another friend is going to take our two proofs and make them into one. So that way, work that you're doing is going to help, let's say, 50,000 users. The work that I'm doing is going to help another separate 50,000 users. And then the work that another party that's going to be doing to aggregate our proofs is just making it easier for everyone else to verify the block, right? And this is really powerful because, again, as more miners on board the Psy Protocol, the better our user experience is, the faster your transactions are going to go, and the more people that we can handle. So it's the first time that with blockchain, we would be able to support something like a viral growth app, like an app with 1 million people using it at the same time. Because thus far we haven't seen a single app like that on crypto, and it's no surprise because if you tried to get 1 million people using Ethereum or even Bitcoin at the same time, you'd be waiting weeks, if not months, for your transactions to be processed, right? So yeah, like big difference there is that instead of having the work of those slightly slower miners go to waste, we're actually combining all of the electricity, the compute power of all the miners to provide a better user experience for our users.
Yeah, that's a great breakdown, Carter. That helps me really understand it. So you're utilizing computing power that was essentially going to waste, but you're kind of funneling that to be used and solve, the problem, or, all at once. I guess in a world, you could argue that proof of work could essentially become greener than proof of stake, right?
Absolutely. Because in proof of stake, every validator still has to validate all of the messages. It's just that you have fewer number of validators. So you can imagine it's like, there's those banking, what is it called? Zelle or whatever. You've got
Yeah.
like, I think JP Morgan, you've got Bank of America, like there's a bunch of banks that work together on it, and they all verify their transactions. And proof of stake is kind of similar, right? But what we've designed is a system where only one person needs to verify each transaction. So you're right. We're actually greener than some proof of stake solutions. It's very cool.
Let's talk a little bit about the Psy protocol here, and how Psy use zero knowledge proofs to scale while staying fully decentralized.
For sure. So the main thing that you want to take away from this is that we use a technique called recursive zero knowledge proofs. And all that means is that whenever you do a transaction on Psy Protocol, what you're actually sending off to the network is zero knowledge proof that that transaction is correct. So anyone around the world could take that proof, verified, and know that whatever transaction you executed on your own machine, that it was done correctly and that it's valid. So like, just to give you an example of what that means, like, let's say I want to send you $100,000. Well, maybe I don't have it, right? If I could generate a proof which would say that I could send it to you, but I didn't have the money, right? Then that would be an invalid proof. But we use like we call it proof of math to prove that users' transactions are correct. And then what the network is actually doing is taking those proofs and it's generating like a proof that your transactions and my transactions are correct, right? And then we'll maybe generate a proof that Billy's transactions are correct and Bob's transactions are correct, right? So now we've gone from 4 proofs. We've got a proof of Billy's transactions, Bob's transactions, Carter's transactions, and Brian's transactions. We've took those 4 proofs, and what the network does is it takes those 4 and converts them into 2. Right? So now to verify all the transactions, you just have to verify 2 proofs. And then we take those 2 proofs and we generate a proof that those 2 proofs are valid. And the cool thing is that the time it takes to verify all of these proofs is exactly the same. So the time it takes to verify the proof which proves that 4 proofs are correct is the same as verifying one of the transaction proofs. So the network is decentralized because anyone can participate at any step of this process. And the really, really cool thing is that the people that are actually aggregating the proofs don't know the content of the transactions that they're aggregating, so they can't censor you. So it's like, let's say they don't like that. I don't know, maybe I don't want to support users from England because I just don't like English people. I love English people, of course, but maybe you don't like English people, right? Some people, Revolutionary War, that we've got some old grudges, right? Down with King George, right? So we don't want to do English transactions. If you're running an Ethereum node, you can censor them because you can see where the transactions are coming from. And as a validator, I can selectively say, not from me, King George, right? But with Psy, when you're aggregating those proofs, you actually don't know whose proofs you're aggregating until the block is already finished. So there's no way for you to censor people. At the same time, rather than having an oligopoly, so all these sort of predefined people that are, validating the transactions and deciding what in fact is a valid transaction and what is not. Instead, we have a purely math-based system. Everyone is invited to participate. So you're going to have people from all corners of the world, people that have never met each other, participating and mining Psy. And there's no permissions. You don't need to own a bunch of Psy. You don't need to become friends with us. You can even talk shit about us. I don't know if I'm allowed to curse, but I just did, right? I guess I can. But you can talk shit about us all you want, and you can still participate in the blockchain. So, and I think that is a rather unique thing for high performance blockchains.
Yeah, that's super unique, the way you put it there. And I could imagine Psy could support thousands and millions of users transacting at the same time.
Yep. And
Yeah.
if even Solana, by the way, we love Solana because again, the reason why I was a proof of stake fan and why EOS was the first big proof of stake blockchain. So I was a very early proof of stake supporter. And the reason why I supported it is because I believed that it was very important for us to scale the values of Bitcoin, other applications, into more users, right? Like your positive impact on the world is your impact per person, so how much good you can do for an individual, multiplied by the number of the people that you can help, right? So if EOS could help us, help more people, then I'm all for it. And Solana's done a great job of that, but it's time to take things to the next level. And as you mentioned, now we can do it for millions of people and really make the internet a more decentralized and more fair place.
Very nice. So what's the most exciting real world use case for the Psy protocol?
There's so many. So I would say one of the big ones that I'm a super big fan of is PayFi. Frankly, existing blockchains cannot scale to the point where you would want to do something like credit card processing. And on top of that, commerce, right? So like we've got payments in our stack, and then blockchain has sort of always had this promise of I'm going to be able to trade with anyone and trade any goods uninterrupted, uncensored by governments. And that was sort of the original promise of Bitcoin. Bitcoin, instead of becoming this cash and this platform for commerce, became digital gold. But now we can build an Amazon scale, an eBay scale, trustless place for people to, trade with each other, to do commerce around the world, without having to worry about, maybe Amazon is going to deboost your seller rating, or, maybe after Amazon, and we like Amazon, we like AWS for some things. They've been helpful for us in the past, but we're talking more about the other departments, right? That have, perhaps, let's say you invent a great new product and you list it on Amazon and it's doing very well. Well, Amazon will likely come around after a year of you spending money on R&D, copy your product, make it an Amazon original, and place it above you in the search results, right? Like these kinds of monopolistic, unfair practices by the platforms that we use every day can go away with Psy for the first time. Because again, with smart contracts, everyone is exactly the same. The rules are the same. You can't just say, okay, I'm Amazon, I own the website, so I'm going to ban your account. I'm Amazon, I own the website, so I'm going to deboost your listing. I'm eBay, so I'm going to decide to increase your fee from $10 to $100 because fuck you, it's my platform, right? Mm-hmm. So we can do away with this unfair internet and make the internet a fair place. So like that's what we're most excited about. Now there's other cool stuff like order book dexes. You can think that full Binance experience coming on chain. So as a user, you get the same user experience you like, but you don't have to worry about Sam Bankman-Fried's girlfriend taking your funds and gambling with them, right? So yeah.
You kind of hit a thought in my mind there when you said eBay. Why don't we have a mainstream on-chain business like an on-chain eBay right now?
How many people need to use eBay concurrently for eBay to be profitable? Dude, 100,000?
Yeah.
Probably 100,000?
Yeah.
More?
Yeah, probably
right?
more.
Probably more, right? Like we all know tech companies are not profitable until they hit a certain amount of scale. This is the web business model. Like the whole business model of the internet is that Uber is still losing money, or maybe they just started turning a profit because they needed 1 million people to be able to use it at once in order to be profitable. But the thing about blockchains, as they said, the fastest blockchains in the game before Psy can do 9,000 TPS. That's 9,000 users can use it can do 1 click per second. And as we know, we sometimes like to click around, right? You can imagine there's a new Yeezy shoe drop or something, right? And you got 1 million people clicking one button, and that's only one pair of shoes. So the reason why we haven't seen on-chain eBay is because the business model of eBay, of auctions, requires lots of concurrent users to be profitable. And frankly, with existing blockchains, it's not just difficult, it's impossible to reach that scale because the blockchains can't process that many transactions per second, right? You couldn't build a profitable eBay, and no one will invest in making an eBay on chain because it could never be profitable. So yeah, like that's why we've seen with, frankly, with blockchain, the use cases have been pretty limited to high value financial transactions where, if you're doing $100,000 transfers, you could have an application that maybe has got 100 users a day and still be making bank, right? It's a lot of money going through, right? We see sort of gambling kind of things. You could be a profitable casino and, hey, people want to gamble, people want to do what they would do. That's fine, right? But you could be a profitable casino with 50 to 60 users, right? You got 1 or 2 big whales that might be enough on its own, right? But if you want to make a mass market tool that's going to need millions of people that frankly is going to be able to help millions of people with whatever task or whatever thing they want to do on the internet, then you're shit on luck. And that's why, again, crypto's use cases, like this dream of Web3, of the internet becoming more like blockchain, just has not happened because we can't do it. We can't support it until Psy. So that's why we're building Psy.
No, I love that. And that's a great breakdown. I think just recently, just like a week ago, I remember reading like Solana had like 100,000 TPS, and that was like a stress test. And, I was actually, I thought it could go even higher at that point. But that kind of puts it in perspective. Yeah. What's that? Yeah. Now you can't.
What is Solana peak TPS? Let's see. Solana peak.
I think it was like 100,000.
And we love Solana. By the way, we work with Solana Foundation tons of cool stuff because again, they can't do 1 million. They've been the best at bringing the value of Bitcoin to more people, right?
Sure.
they've understood why performance mattered, even when people are like, oh, everyone says TPS, it doesn't actually affect your user experience, and they proved everyone wrong.
Yeah,
But
it's
let's
a. The only reason I remember it sticking out, it happened like a week ago or something. Maybe recently, more
all right. So
recently,
it's a
but
program that doesn't do anything. It's called a NOOP program, a no operation program. So 100,000 times zero is well, you can do the math. But we love Solana. We love Solana, right?
yeah,
We
yeah,
love
yeah.
Solana.
Sure. No, there's a lane for a lot of these to succeed, but I was just kind of putting it in perspective in my own mind. Kind of let's wrap it up a little bit on what's the first business you would like to be fully on chain when Psy's live? I know I'm putting you on a spot here, but
Amazon,
it
eBay, payments. I think payments makes the most sense.
makes tons of
Um,
sense, right?
yeah, because we're cheaper. Like again, whenever you have these limits on the number of transactions you can process, what happens when the network gets congested? Well, you've got to determine who's going to transactions getting processed and who's not, which means the fees are going to go up, right? With us, you don't have to worry about fees going crazy. So I think payments makes a whole lot of sense.
Yeah, definitely. Carter, I want to give an opportunity for our audience to learn more about Psy Protocol, learn more about you, give a shout out how they could find you and on crypto Twitter, or if that's a website, give it on a shout.
For sure. At CMPEQ or head over to psy.xyz. That's psy.xyz.
And I'm going to put all those links down below for everyone so you can learn more about Psy Protocol. An awesome interview. Carter, really appreciate you jumping on the podcast today.
Thanks so much for your time. Thanks for having me.